So, welcome everybody. And while we wait for more people to join to this webinar, I just wanted to um, take this opportunity to welcome everybody for the English session of the second webinar led by the EO4SD Forest Management Consortium. The topic of this webinar is emerging opportunities for improved forest monitoring. And today we will be joined by two presenters from Indu4 in Finland. It will be Rabin Skaudel and Saija Papunen. Both of them have experience in forest resource monitoring and also remote sensing and GIS analysis. So without more to say, Rabins, I give you the floor.
Thank you, Daniela. Good morning, good afternoon, and good evening, everyone. Thank you for joining this session. So, like Daniela already mentioned, so today's topic for this webinar is emerging opportunities for improved forest monitoring. So, I'll be presenting the webinar. So, my colleague Saya Popinin, she will be assisting me throughout this webinar, and also she will be collecting your questions, so to be addressed at the end of this event. So, before going into the presentation, so I would like to introduce a couple of housekeeping items. First one is that at the end of this session, we'll have a Q&A session. So if you have any questions regarding the topics, regarding the presentation seminar, so please free to drop in your chat box, and my colleague will collect and we try to answer the questions as much as possible. And if there is some time restrictions, so you cannot answer your questions, then we make sure that we will answer your questions by email. Just to let you know that this session is recorded. That means that the purpose is that to make this content available for other users who might have missed this session. So this session will be recorded, and after the ending of this session will upload this to our website, which can be accessed anytime. And also, by default, your microphones and your cameras should have been turned off. But if it's not, then I request you to take it off so that it will not cause any kind of disturbance during this presentation. Thank you so much. So now we go to the context of the webinar. So this webinar is a part of European Observation for Sustainable Development project, which is ESA initiative. So ESA is European Space Agency. The main primary objectives of the project is to support international finance institutions and their client states to harness the benefit of Earth observation data in their development operation that could be at the national and international level. So to build up this support, so we are like combined many partners. So you can see on the bottom border. So we have 6 different partners led by GAP to fulfill this objective. So in fulfilling this objective, so our idea is that to provide the convincing demonstrations of the benefit and utility of EO data to the IFIs and the client state. So we do this by engaging with the IFIs and the client state at the beginning of this project, and we try to identify how we can engage so that we can demonstrate these benefits of EO data. And also, we want to cover different geographical regions. So, for example, at the moment, we have a project and cases in Asia, we have in Africa, in South America. And also, we want to make sure that within this project, our products and services are user-driven. So they are not just random from us, but they are actually addressing some of the challenges that IFIs and client state having. So there is some added value to this approach. And also, without the quality control, then it's very hard to trust the data and the product. So we make sure that whatever we delivered, it comes with the quality control and quality assurance. So with every product, we deliver this. And as this is not only one demonstration case, but this is like the ESA wants to they are committed that this kind of initiation should be sustainable. So that's why we are there is a big part within this project, which is technology transfer and capacity building. So within that, we have lots of these workshops, we have these webinars, and also we exchange different kind of materials. and online trainings and that kind of item, so that the capacity building is also key component within this project. So basically, what you can see here at our topics for the webinar. So first one you see, it's it's not a webinar, but it's an online course or online items of collection of various kinds of Earth observation data, procedures, the guidelines to process them, to use different kind of data for different kind of products. So all sort of these available data sets and the guidance are compiled into different topics. So you can visit this anytime. And we have bundled them into different topics. So for example, you can go to each specific topic and assess all these materials anytime. And from second to the last, you see different topics. These are the webinar topics, from the application of EO forest monitoring to the land use land cover mapping. And the first webinar, this application of EO project for forest management, is already completed. But don't worry, if you are still interested, and in case you have missed this, there is a chance to visit our website and you can access the recording. And from now, you can see like there are many topics that they will be held at different times. So to know more into the details about each topics, please go to our website. So you'll see the details. And just to let you know that some of the topics are provided in multiple languages. For example, we have English webinar, French webinar, and Spanish webinar. So please visit our website and check into the details. So some of the registration are already open, and other will be open at least a couple of months before the webinar. So now let's jump to today's topic. So in today's topic, we'll be talking about firstly, we talk about the observation for generation of activity data, which is a very crucial data for emission estimation. So we will look how the current EO data can be used for accurately estimating this activity data. And secondly, we will check the current opportunities of forest monitoring. So we'll look into the latest available data sets which has to offer and which has currently support the generation of activity data. And the third, we will go into the future. So this section will look ahead into the coming decades, particularly into upcoming satellite missions and ways to assessing these EO data sets. And then finally, we'll have a Q&A round, so we'll try to answer your questions. So let's go to this Earth observation data for generation of activity data. So we'll look into how currently EO data can be used for generation of activity data, especially in the agriculture and forest land sector. So activity data, what it records is it's a data on the magnitude of human activities resulting in emission or removals are taking place at a given period of time. So when reporting to IPCC, all sectors, they need to report on their emission with the time period, with the given time period. So basically, you can see on the left, pretty simple equations, and then you can see the activity data is the primary data for the estimation of emission. And often within this agriculture and the forest land use sector, the activity data can refer to, for example, different type of land use or extent of forest loss, and these all can be expressed in terms of the area or reporting period of time. And these levels, like for example, in the right, you can see the table how to generate the activity data. For example, there are different approaches. 1 to 3 approach. The one is very unidimensional, very simple, just account the net change. But approach 3 is more detailed, much more spatially explicit kind of information on the land cover and land use change. So this level are, for example, based on the characteristics of the available source of input data. And one of them is like, of course, the Earth observation data. For example, high resolution EO data with ample coverage, and of course with a high temporality, it can use for generation of a wall-to-wall mapping at higher level of details. That means with using this EO data, we are able to generate a really good details of activity data. Here you can see, like for example, what activity data derived from EO Earth observation data can use to derive. Like for example, we can have a very good accurate land use and land cover data. This can provide the spatially explicit information on the types of land use and the land cover in the given area. So this kind of classes can be classified into, like, for example, with 6 different classes, which is defined by IPCC. But again, we have a very good EO data coming. With the good EO data, good spatial resolution, good temporality, we can further classify these classes into the subdivision. So further divided into more subcategories, so that will better reflect the information on the ground. So mapping these land uses as well as their changes over time, it can lead to estimation of emission from these sectors. So refined category in combination with a refined emission factor, of course, then it will lead to better estimation of the emission from the agricultural and forest land sector. And another key things here is the deforestation and degradation. So, for example, this deforestation and forest degradation, it's one of the leading item that generate the high emission in this forest and land use sector, and therefore its importance is like very high to understand. Like, for example, the impact of it in land use chain and also in the carbon dynamics. And because of these detailed estimation of forest loss, like, they are really needed to quantify the contribution of each disturbance, for example, deforestation activities to the country's emission. And these estimations are also to align with the country definition of forest. And another activity here you can see is the fire activity. So it's very important to monitor the frequency and intensity of fire in the forestal land, because fire not only create the emission, but also it has a very bad impact on the diversity. And fire also, so you can the carbon stocks in the forest and also the biodiversity has an impact. They can be they have a several impacts because of the fires. That's why these need to be monitored. And other things such as the vegetation health and productivity. So all these things can be like monitored, that can be detailedly mapped using the activity data from the EU database. So in overall, you can see how this remote sensing can be very useful for providing very detailed information in these agriculture and land use sector, and to identify their impacts on the environment.
Ravins,
I
I
think,
think we
yeah,
have an interactive component right now.
yeah.
So um,
Oh, yeah,
I, we are just testing this component out for the first time today. So please bear with us.
yeah.
Yes,
So
I will now be launching.
yeah, so we'll distribute a question, a poll to you. So please, you can answer these questions by clicking to the options, or if in case if you have to provide some answers, please do so.
So I see that we're being joined all around the world. I see Germany, Finland, Italy, Portugal, Chile, Pakistan, Australia, New Zealand.
Really
Yes,
great to see.
nice to see so many different places and all around the world.
Ethiopia, Turkey.
All right, Janela, so how is it poll? So will we continue now?
Yes, I think we can go for the
Um,
second question.
yeah, I think
Um,
it's good. Yeah.
Yes. I think I will close this first poll for now. And Will we go to the second one already?
All right, yeah.
So let's go for that one. All right.
Yes. So the second question, have you used Earth observation data for activity data reporting? So far, we have 11 responses with a 50-50 match. With more people right now saying that they have not used activity data before. In that case, this webinar series might be of interest in the upcoming webinars. But also, if you have already used it, we will look into some of these products in further detail in upcoming webinars.
Yeah.
As well.
Okay.
All right.
All right. So things moving. So we talked about the how remote sensing data or observation data can be used for activity data, and it's good to note that there has been a lot of improvements within the remote sensing data. So over the times, for example, if you see like before 2000, we had a very low resolution data set. The temporality was very low, but now these new missions are emerging. The quality is increasing, so the availability, accessibility of remote sensing also it's more increasing. And remote sensing data is now provided consistently, and the methods behind the derivation of remote sensing product are being constantly updated. And this is due to the international need for ongoing monitoring of the forest and associated land exchange for international convention and programs, for example, a RED Plus. And also, we have to acknowledge the fact that the importance of international policy, such as the free and open data policy. And this international agreement and policy have also led to guarantee of free and open EU data, which can result in increased availability of satellite data now and also in the future. And the frequency and the quality of the data is constantly being improved, and also it can be used for a series of uses related to monitoring land use and climate. And because of the different kind of sensor are available, not only the forestry and land use sector, but it has been now can be used in the various other sectors. For example, now with the good level of data, we can have a very good and accurate data on land cover and land cover change. We can also try to identify the drivers for each disturbance or each changes in the structures of the biomass and the land use. And also, like we discussed in the earlier about the activity data, so getting these very detailed levels of data on activity would ultimately improve the generation of the emission from the land, forest, and land use sectors. So that's how this Earth observation data has assisted in getting the better activity data. And also, just to let you know that the things will keep improving in the future also. So there are some resources available if you are interested and if you want to expand your knowledge. For example, GFOI's OpenFRV, it's a very useful platform. So there are lots of tutorials, standard operation procedures that are compiled. So you can visit it anytime and expand your knowledge, how to process EU data, what kind of methodology algorithms you have for processing and developing algorithms and developing activity data. So, and within this project also, like I said before, we have compiled various materials, for example, tutorials, online courses, recordings of webinars. So we have compiled them and put into different bundles there in our website. So you can visit there anytime and access this information. So and another thing is this webinar series we are talking at the moment. So this is like second webinar, but we have 9 different webinars provided within this project. And for example, here you can see there are 9 different topics from second to the last one, and are happening in different time of the year. And For activity data generation, I'd like to highlight these three topics. For example, the introduction one, which has already lots of resources which could be used for getting your knowledge and the guidance for the derivation of the activity data. And the tree cover first mapping, which is happening in May and June. There is two time because we have this webinar for different language, English, Spanish, and French. And the last one is the land cover mapping. So these all topics, I know other topics also are related because how to assessing the EO data, the processing, they somehow follow the similar kind of methodology. So all are related, but just wanted to highlight these three in case you want to learn more about the getting and generating activity data. Okay, so here I want to show a couple of examples. So this is the example of Cameroon. So our partner GAP has contributed with the assessment of activity data. So emission factor also, and also the transfer of capacities and technology that was held within this project. So for the production of activity, you can see there was 3 satellite data were used, Landsat data, Sentinel-1 and Sentinel-2. So based on that, the first land cover map was developed, and from the land cover map, then you have the activity data, which is the change area was identified. So the final activity data derived was change in forest area. So such analysis like had added like for the estimation of the deforestation and degradation. So which in combination together with emission factor from forest inventory and carbon accounting, it also added the estimation of forest-related emission. So the result from this work has been transferred through workshop and also on the job and field surveys. So this is a big part of capacity development within this project. And another example here you can see in Gabon. So our partner CLS has added the production of activity data in the shape of forest cover chains and its driver. You can see in the left, as well as the estimation of total area of deforestation and degradation and regeneration. So you can see on the right. So in the left side, you see there are like wall-to-wall forest map that was produced for the Gabonese Agency of Space Observation Studies. So based on this project, and 2 maps were developed for 2010 and 2015. So an analysis of the change in forest area was carried out to identify the drivers of deforestation and the forest degradation. So you can see here, so there are a couple of drivers on the listed, and understanding the land use changes and also the drivers, like how this land is changing and to what category it is changing. It's very important. In that way, you can even better understand these land use change dynamics and also have the better accuracy in estimating the emission, because you can track these changes between these very small subdivision categories. For example, forest into the rubber plantation will have different emission than the forest into some oil plantation. So these kind of different data and the details can be captured with better data. And in the right, still it's a Gabon and analysis of activity data was carried out to support the forest reference emission level. So for each deforestation and degradation, so identification drivers of changes was undertaken, and which is needed to, of course, to specify the amount of emission that originates from the land use changes. So it is for the reporting of the framework of REDD+ and emission reduction based payment, and the land use changes are definitely are of high importance. So these are the 2 examples I showed you. Now let's go to the current EO opportunities for forest monitoring. So I think you have heard and maybe probably use different data for forest mapping and monitoring. So we'll talk. I think you might have also encountered Copernicus Sentinel program. So it's an integral part of ESA's forest monitoring efforts. So it's a Copernicus program. So it's a European initiative that provides free and open data. For example, you can see that there is daily 300 terabytes of satellite data that are distributed per day. And the good thing is that it's available free and very open and easy to access it. So within the Copernicus program, also the Sentinel missions have been made to replace the older Earth observation. For example, ERS and NV sets. So the ESA is committed so that there is a continuity in the data. For example, some of the older missions are coming to the end, or some of them are already dead. So therefore, to have the continuity, the ESA is committed to send the new mission so that data is coming frequently, and also with update on its technology that even get better. So basically, you can see there are different missions, Sentinel-1 to Sentinel-6, and these different missions, of course, they focus on different aspects of observation. For example, some in land sector, forest sector, some atmospheric, ocean, and so on. In the next slide, I will explain this a bit. Yeah, for example, here you can see the Sentinel missions are that series of satellites launched by the European Space Agency, providing the continuous and high resolution of observation data for environmental monitoring. So Sentinel-1 is SAR, so it's a radar. So the good thing about radar is that in many parts of the world, you still have challenges because of the high cloud cover. And in that places, this optical sensor has a lot of challenges, so you cannot get the desired data set within the desired time. So in that way, this can play a complementary role. So because radar can penetrate the clouds, and also it can map the Earth day and night. So it doesn't have to depend on any source of light. It has own source of light. So it's keeping mapping the Earth 24/7. So it is very valuable data. And the Sentinel-2, it's been mostly used for forest mapping and vegetation mapping. So it's an optical sensor. And Sentinel-3, it's a marine observation. 4 and 5, they are mainly focused on the air quality monitoring. And the Sentinel-6 is a sea surface. So if you want to know more, please visit this website, so you'll find more into the details. But I'm highlighting 1 and 2. This is because they are assisting each other. For example, like I mentioned, this, the challenge with the clouds can be a little bit tackled by using this Sentinel-1 and 2. And sometimes there have been developed lots of platforms, for example, real near-time monitoring of forestry, like deforestation alerts, all these things, they are mainly based on this SAR data. So Sentinel-1 can have this kind of a very important role in the monitoring of forest and forestry technology. So what are the current trends? So we discussed about the different kind of data. And now, like for example, I want to show you this graph. You can see from on the bottom side, there is like a resolution, how it's shifting from the poor resolution to the high resolution. So over 1 kilometer resolution now to 10 meters. And that time when the data was very scarce, so it was not maybe in the open in the beginning or before 2000. At that time, we had these global land cover maps. They are very static, and there was no any updating, so it was very static and isolated maps. And the course resolution was also not as detailed as you would like wanted to have effective monitoring. But with the availability of more sensors and developing within this mission, for example, Sentinel, MODIS, Landsat, all these things are coming, and the open data policy, which has distributed its data for free. Now we can have a very, very good and very detailed product, global product. For example, you can see GHSL, for example, dynamic world cover. So these all kind of products that are easily available, and we have to thank to this open data policy that's happened some time ago. And for example, here you can see this is climate change initiative land cover. So first you see there was 300 meters resolution, then it changed to 100, and now we have even better, like world cover map. It's a 10-meter resolution, and this has recently released, so you can access this data. So data for 2020 and 21 are already released, and these are based on the Sentinel-1 and 2. And you can see below there's like a couple of graphs and a couple of like what kind of classes are defined within this global land cover map. And the overall accuracy is 75%, which is pretty good for the global land cover data. So these all things like improving in a sense that with the availability of the data, with the availability with the improvement in the technical specifications within the different missions, these kind of products are globally available. And also, Another important vision here is the Biomass Climate Change Initiative product. So it's a set of global map of above ground biomass, which aims to support the quantification of biomass change across different epochs, like between 1990 to 2020. So the product is based on the combination of data from different missions, for example, Sentinel, for example, Envisat, for example, Jackass, ALOS 1 and 2. So these are combination of multiple data from multiple missions. So these products provide high resolution. So it's a 100-meter resolution product and up-to-date information on the biomass. So this is very crucial data and very important data for understanding the carbon cycle, informing the sustainable and land management practices. And at the moment, the maps are available for 2010, 17, and 18. But the latest map for 2020 is in the process of developing. At the moment, actually, it's in finalizing of validations. So after that, this should be available. So the importance of this mission is that by providing this accurate and timely biomass information, the Biomass Climate Change Initiative product can be helpful not only for the monitoring, but also the policymakers, resources, and the practitioner monitoring land use changes, evaluate the effectiveness of the conservation effort, and also navigate the impact of the climate change on the biomass. So this is this could be very useful information. And another data, I'm not, if you are aware, is NICFI, so Planet Scope Surface Reflectance Mosaic, our analysis-ready data that was providing on land surface reflectance. So it covers like quite a range of area. For example, the tropical part of Africa, America, and Asia. You can see in the graph. So this product is not available every part of the world. And the mosaic are based on the 4 bands, so blue, green, red, and near infrared. So and the temporal and the resolution is like less than 5 meters. So these data are available for free. And the temporal resolution of the data is a biennial. For example, it depends actually. For example, before 2020, from 2015 to 2020, there were available only the biannual mosaic. So we get 2 mosaics in a year. But after 2020, now it's changes. Now we can get this a mosaic every month. So the temporal resolutions somehow have improved a lot. So and the data are also available through various platforms. For example, you can see the list here. For example, Google Earth Engine, Planet platform, SEPAL platform, Planet Client command line, and so on. So additionally, the data is also available in some of the GIS application and softwares. For example, ArcGIS, QGIS. You can install a plugin, and if you get the credentials from the login details from the NICFI, you can apply there, and you can already visualize and download this data from ArcGIS and QGIS. And another platform I like to present here is SEPAL. So SEPAL is a powerful tool for mapping, monitoring changes in land use and land cover. So it's a platform developed by FAO, Food and Agriculture Organization of the United Nations. So SEPAL, what it does is provides user with access a wide range of satellite data and allows them to map different types of data related to land use and land covers. So you can go into the platform and you can access the data, process them, visualize, and also download. So this is very handy tool. So one of the key benefits of the SEPAL, it's accessibility. The platform is designed to be easy to use and also easy to access by users with a different level of technical capacity. And SEPAL is also very free to use, so which makes it even attractive options for different users. For example, researchers, NGOs, government agencies who need to have this kind of data for like monitoring various land use sectors. And another advantage of SEPAL is also that it is based on the Google Earth Engine platform. So that means that it allows for analysis large-scale data sets. The users can process and analyze large amount of data quickly and efficient, so which is particularly important when monitoring changes in land use and land coverage over time. So in a sense, in a like nutshell, it's a very useful tool for anyone who need to map, who need to process the different EU data for monitoring change in land use and land coverage. And yeah, its accessibility, it's easy to access, and also the technical. You can, for example, different people with a different level of technical capacity can also feel a little bit easier to perform this platform. And another platform I like to bring here is the Copernicus data space ecosystem. So it's a powerful, it's again the similar kind of platform for assessing and sharing data related to Earth observation and climate monitoring. So this was developed as a part of Copernicus programs. The data space ecosystem, it provides users with access to a wide range of Earth observation data, including satellite data and other climatic data. And the platform also offers tools for processing data and also visualizing. And I'd like to highlight one of the key benefit of the data space ecosystem, its ability to support collaboration and data sharing. So the platform allows users to share data, collaborate between different stakeholders, like a different part of the world under the same project. So this is particularly important in the context of observation and climate monitoring, where the collaboration between different stakeholders can lead to more efficient solutions. So it's a more flexible, so in a sense that it can allow for integration of new data sets and service over time, so it will keep improving. And this means the platform can adapt to changing user need for accommodation of new technology as they are available, and they're flexible and essential in the fast changing field of observation and climate monitoring. At the moment, Saya, would you like to share another poll?
Sure. We actually have 2 polls left. So
yeah, we can.
First one is related to using Sentinel data for activity data reporting. Just a quick one. Okay. Seems that quite many people have been using Sentinel data for AD reporting.
Okay.
Approximately 2/3 of the responders.
Okay.
All right. And then we have the last poll, 4th poll, which is related to the most common drivers of activity data in the projects that the participants are working for. It seems that there are quite many different things: land use, biomass estimation, land cover classification, forestry. All right. Gold mining, fires. Okay, so nice variability of different drivers.
Yeah, very good information. So, okay, thank you for your poll. So now we come back to the presentation. So I was talking about the Copernicus data space ecosystem. So still it's in progress. So for example, ecosystem will be available. This will be available by the end of this year. So the Copernicus, this ecosystem will be valuable resource for anyone working in the field of observation and environmental monitoring. So its ability to support collaboration and provide access to a wide range of data, and also offering tools for data processing, visualization. So it makes it like a really useful and powerful tool to have. So over the last month, the Copernicus data ecosystem has been continuously upgraded. So in order to include more service, so we expect more service to be available by July 2023. So pretty soon, and this service include kind of access to the all Sentinel archive. So before we discuss about the current mission, so now we'll go to the future mission. So what kind of missions are coming in the future? So one of the very awaited mission is BIOMASS mission. So BIOMASS mission, which is scheduled to launch in 2024. So it is a space-based radar mission. So designed to provide the critical information on the status of forest and their changes. So the mission would have the P-band radar imaging system, so which allows even better measurement of the forest biomass structure and changes. So the P-band is a very longer wavelength, so it will have a better penetration within the forest, and also will be helpful to derive more accurate and detailed information. So the mission will expand the knowledge of the role of forest in global carbon cycle, and also it will help us better understand the drivers of deforestation and forest degradation. So data from the mission will be used to inform policy decision makers related to climate change, biodiversity conservation, and the sustainable land management practices. So in overall, the BIOMASS mission is expected to be significant contributor globally to monitor protect the earth forest, and also to support various range of applications in the field of climate science, ecology, and natural forest management. And Sentinel, I already talked about the mission, Sentinel mission, but again, Sentinel Expansion mission, the European Space Agency Sentinel satellite type, they provide essential source of information for monitoring Earth environmental and natural resources. So building on the success of the initial Sentinel mission, so ESA has launched like a series of Sentinel Expansion missions to enhance the capacities of Sentinel programs. So this mission will they are aiming to provide more advanced data on the range of observation application, including land monitoring, ocean monitoring, climate change monitoring. So, and one of the key missions which the Sentinel Expansion program has is the Sentinel-1 radar-based system for Europe, that is ROSAL. For the resource monitoring professionals, the ROSAL mission offers a powerful new tool for tracking change in Earth land surface. So it will provide the detailed radar data of high resolution, and the mission will also allow to gain insight into the natural resource management challenges, and also make more informed decisions about the resource use and conservation. So the data from the mission can be used to support wide range applications. So for example, monitoring health and agricultural crops, to tracking change of forest over times, and so on. So the Sentinel Expansion mission, the ROSAL mission, it should be a significant step forward in Earth observation and natural resource management. So with their advanced capacities and increased data availability, this mission offers a powerful new tool for monitoring the health of our planet, and also managing them, like how to managing the different sector in a more sustainable way. So, and another upcoming mission is from the Landsat. So Landsat, I think it's one of the longest running Earth observation data provider. So they have been continuously providing us useful information from like over 4 decades. So the Landsat Next here is the next generation of Landsat satellite program, so which has been providing critical Earth observation like for a long time. And the program is joint effort between NASA and the USGS. And its primary aim is to produce produce and provide advanced image capability to support a wide range of applications related to land use, natural resource management, and climate change. So Landsat Next is expected to be to bring number of improvement over previous Landsat missions. So you can see there are 26 bands. So and also some of the bands will have similar characteristics with the Sentinel band. So this will even allow us to harmonize the data between Sentinel and Landsat data. So this again improve the coverage and also help to tackle the other challenges. For example, challenging the land cover and so on, challenges with the cloud cover and so on. And the mission will also support a wide range of applications of not only the forestry, but also for the monitoring of crop health, tracking change in the land, and so on. And for professionals involved in the natural resources management, so Landsat Next can offer like a new powerful way of monitoring and mapping of land's resources. So by providing more detailed and accurate information on land use and land cover, so mission will help to support more detailed, informed decision making related to natural resource management, land conservations, and climate change mitigation. So in addition to its imaging capabilities, so Landsat Next is also expected to provide the enhanced data accessibility and also improve data processing capability. So this will help to ensure that the data from the mission is easily accessible and also used by a range of users, including scientists, researchers, policymakers, and businesses. So to summarize now, we are coming to the end of this presentation. So to summarize, what we can see is that improved new and upcoming sensors, they are offer improved capacities for monitoring land use changes at higher level of details and accuracy. And this can also help inform policy decisions related to climate change, biodiversity conservation, and sustainable management practices. And this also increase, there is also increase in the temporality of satellite imaging, so which will also improve the level of monitoring. So we get more frequent data. That means that we can monitor our forest in more frequent manner. And the inclusion of us like a SAR offer us complementary advantage in detecting forest change. And also it's important for land use areas with high cloud cover, which can be a limitation, like I mentioned, for the optical sensors. And also the policy related to the free and open data, they have resulted in increased availability of satellite data. So this has nurtured the usability and also development of various applications which harness the benefits of EU data at various sectors, not only the forestry sectors, urban sectors, business sectors. These data are now evolving. The application and usability are evolving across various sectors. So overall, the achievement, advancement in satellite technology and the policy promoting free and open data have provided opportunity for improved monitoring and understanding of forest and land use changes, which is crucial for understanding the global challenges such as climate change and biomass, biodiversity loss. So these are the keynotes, and I hope I gave you something like provide you some of the information about the methodology, how to generate the activity data, and also try to brief on the current missions of EU data, and also try to overlook the upcoming EU missions in near futures. Thank you so much. Now I give the floor to Saya and Daniel.